If necessity is the mother of invention, then serendipity must surely be a close relative. Some time ago, I was trying to create a grid of cubes using nested loops when I noticed that Blender tended to lag after the nested loops were about 3 levels deep or so. Curious, I experimented by increasing the number of loops as well as the number of cubes. As you might expect, Blender predictably crashed after the computer's processor was stretched beyond its limits. Loops in computer programming, no matter the language, follow the same principle, which works like this. A portion of code is repeatedly executed for a specified number of times. The number of times is given by a number called the index. In this code, the index variables in the binary section, written here on lines 10, 11, and 12, are known as 4s, 2s, and units. In the hexadecimal section of our code, they are known as 16ths, here on line 37, and units, here on line 38. So if I write a loop like this, 4 units, in range 6, print units, I am telling the computer to count up 6 times starting from 0. Units is known as the index or counter. So this loop will count starting with 0 to 5. That is 6 counts, same as the range. The range will be equal to the number base itself, which will also specify the number of digits with unique symbols. So for the binary or base 2 number system, the range will be equal to 2, as indicated here on lines 10, 11, and 12. For the hexadecimal or base 16 number system, which has 16 unique digits, the range will be 16, as indicated here on lines 37 and 38. In Python, the part of the loop to be executed is indented. In many other programming languages, the part of the loop to be executed is placed within curly braces, but Python uses indentation. For each number system, the number of loops will be equal to the number of place values. For the binary number system, our code has 3 loops, 2 of them nested. So the code will produce 3 place values: the 1 place, the 2 place, and the 4 place. When you place a loop within another loop, that is, when you nest a loop within a loop, the nested loop will be executed for a number of times equal to the number specified in the range of the first loop, or the loop before it. You can now see why our code works. Since 1 is the maximum digit in the binary number system, each loop is given a range value of 2. This ensures that the loops will only count from 0 to 1. For the hexadecimal number system, there are 2 loops, so 2 place values will be created: a 1 place and a 16th place. For the loops in the binary number system, the computer will simply count as instructed. However, this simple scheme is not possible with the hexadecimal number system. This is because in order to maintain a unique symbol for each digit, the digits greater than 9 from 10 to 15 are represented by letters of the alphabet. So if we wanted to write numbers in hexadecimal simply by running a loop and counting with the index, we would have to use the hex function in Python. The hex function is HEX, the X function. This is HEX, and you put the number to be converted to hexadecimal within the parentheses. This would make things rather ungainly. To eliminate this prospect, I simply opted to create 2 arrays or lists, which I called hex 16th place and hex units place, here on lines 33 and 34. In each section, a variable called dec equivalent provides the decimal equivalent of each number that is printed during each iteration of the loop. It is then incremented to the next decimal value after each iteration. I added formatting to separate the digits by one space, and more formatting to create more space between each binary or hexadecimal number and its decimal equivalent. Finally, I also added formatting to create 3 line breaks to separate the output of the binary and hexadecimal numbers. I recommend you check out my tutorial on converting numbers to binary and hexadecimal using denominations of currency. I think you will find it interesting and helpful in viewing this tutorial. If the font size here appears larger than you expected, it is because I increased it. To increase the font size in the text editor in Blender, just press Ctrl and roll your mouse wheel forward. To decrease the font size, press Ctrl and roll the mouse wheel backwards. Run the code by clicking the play button, then click on Window, then toggle System Console to see the output. And as you can see, Blender has printed the numbers in binary and hexadecimal. In binary from 0 to 7, and in hexadecimal from 0 to 255, as we stipulated in our code. I hope you have enjoyed this little Python coding exercise. Thank you for watching, and as always, like, comment, and subscribe. Until next time, goodbye.